Hi everyone, my name is Phuong Nghi Nguyen, and today I'm gonna present my final project for material science class. I'm gonna introduce a high strength material, titanium alloy, um, Ti64. So let's get started. At first, I want to give you an overview about the material. So Ti64, also called Ti6Al4V or Tc4 or titanium grade 5, is one of the most commonly used titanium alloys. This material is known for its high strength, low density, and excellent corrosion resistance. Because of these outstanding properties, this material is used in aerospace industry as well as automotive and biomedical industries. So next, I'm gonna talk a little bit more about the composition of the materials. So Ti64 is composed of approximately 90% of titanium as a base with about like 6% of aluminum and 4% of vanadium. Of course, this alloy gonna contain some small amount of impurities like we have iron, carbon, oxygens, nitrogens, and hydrogens. So the compositions of these properties gonna affect the mechanical properties of the alloy. For example, if we increase the percent of the oxygen in the alloy, then it's gonna result increase in material strength. However, it's gonna decrease the elongation of the materials. So next, I'm gonna discuss about the crystalline structure of Ti64. So Ti64 is a two-phase titanium alloy that consists of alpha and beta phase. In the alpha phase, this alloy is specified by hexagonal structure SCB, while in the beta phase is identified by the body center cubic structure. We'll talk about the phase transformation from alpha to beta of this alloy. At a temperature that's lower than 900 degrees C, this alloy is more stable in alpha phase. As we can see, the phase fractions of alpha phase at the temperatures that lower than 900 degrees C is much higher than the one of beta phase. And at the temperatures that equal to 900 degrees C, um, the phase fraction of alpha and beta phase are equal to each other. This is the phase equilibrium point. And moving above the 900 degrees C, we can see that the phase fraction of beta phase is much higher than um, alpha phase. At this temperature, this alloy tends to exist in beta phase. And at the temperatures that all the alpha phase is completely transformed to beta phase is also called beta transverse temperature. That's approximately 950 degrees C. I will show you my 3D model for alpha TA64. This is the SCP structure. The white sphere is represent the titanium element. The yellow one is represent the aluminum element, and the red one is represent for vanadium element. And next, I'm going to show you my 3D model for beta phase Ti64. So here's is the BCC structure, and again, white is for titanium, yellow is for aluminum, and red one is for vanadium. In the next slides, I'm going to discuss about the physical and the mechanical property of Ti64. Regarding the physical property, this material have a low density uh, of 4.43 grams per centimeter cube. This density is twice lower than the standard steel, which is 8 grams per centimeter cube. Um, this material have a high strength with the yield strength of 880 megapascal, and the ultimate tensile strength is about 950 megapascal. This material is also known for good ductility and the good corrosion resistance. The thermal properties of Ti64, this material has a very high melting point of 1670 degrees C. However, Ti64 have uh, low, very low thermal conductivity compared to other metals, which is only 6.7. Um, Ti64 has the moderate specific heat capacity as well as thermal expansion coefficients. So in the next slides, I'm going to discuss about the advantages and the limitations of TI-64. About the advantages, this material is a high-strength material with low densities, providing a good strength-to-weight ratios. The material is also good for corrosion resistant, as well as uh, it have it has the very high melting point, and TI-64 is also biocompatible materials. About the limitations of the materials, TI-64 is kind of expensive and it has a poor shear strength, as well as it's kind of hard for wedding, which requires some special technique. About the applications of TI-64, it have a various application in many different fields. So here I want to discuss about its applications in aerospace industry specifically. Um, so because of these outstanding properties that I mentioned previously, TI-64 is one of the top choice material for aircraft industry. TI-64 is used to make many aircraft components, such as the jet engine part, uh, and the airframe is shown below here. Um, TI-64 also used to make skin panel, wing box, or landing gears, and the tail cord as well. In the next slides, I'm gonna discuss about the applications of TI-64 in biomedical implants. Um, TI-64 is used mostly in joint implants such as hip and knee replacement. As the picture showing here is the artificial hip and knee made from TI-64. TI-64 also used to make bone screw as well as used in dental implants. The material is also used to make surgical instrument and pacemaker. The last applications of TI-64 that I want to mention is in the automotive industry. As we can see in the past few years, TI-64 has been used to make many car components such as the connecting rod, the intake valves, torsion stop, and many other car components. Here is the image of the connecting rod and the the connecting rod and the intake valve made by TI-64. Um, this is the reference, and that's it. Thank you for your attention and good luck.